Have you ever seen an oil-filled bridge rectifier before? Stick around, we're going to get right into it. Hey guys, welcome to the channel. I hope you're doing well. Today we're taking a look at something that I haven't seen before, which I think is a reoccurring theme on this channel. Usually I can guess what something is when I see it. In this case, I had some help. We've got a label here that says this is a rectifier, metallic, one piece. Something I see that usually I don't get a chance, takes a little bit more work to find. In this case, they have it printed right on it, September 1956. Let's go ahead and take a look at this. It's got some other info on here that we can go into if you want later on in the video, but check this out. So this is an oil-filled selenium rectifier. And again, if I didn't have the box or I didn't have any of this notation on here, I may have been able to still tell what this is, though at first glance, I mean, it looks like something you would grab your can opener and pop this open and maybe feed your dog, or maybe have a pull tap and pop it open and share it with your buddies, or don't share it with your buddies. But in this case, I have never seen a rectifier oil-filled in a can, and I've spent a fair bit of time looking online, and I still have not found this unit. I'm curious if any of you guys have ever seen this unit. I believe that this was used for military application. It's hermeneutically sealed, meaning this thing will really last a long time. But going back to identifying this part, if we didn't have this indicator here, or the fact that it says literally right on it that it's a selenium rectifier, a good giveaway here are these 4 prongs on the top. You'll notice we've got 2 that are yellow and 1 red and 1 black. And these 4 terminals are not like what we normally see in electronics. You see, we've often got 2 terminal components, like, say, resistors. Here's one here. Often seen with 2 leads on it, maybe even capacitors. Again, here's a capacitor with 2 leads. An electrolytic capacitor here. Sometimes we'll see more than 2 leads. In this case, 3 leads. Sometimes many more leads. In this case, 16. This is a RAM chip that I just replaced. It has failed. But in this case, we have 4 terminals. And these 4 terminals definitely denote that this is a rectifier. And a rectifier is basically a diode, as seen from these diagrams here. This is the schematic symbol, or the electrical symbol for a diode. If you don't know what a diode is, don't worry, stick around, and by the end of this video, you probably still won't know what a diode is, but you might be somewhat entertained. So today we're not going to go into the theory of diodes. We're not going to talk about PN junctions and doping. No, not that type of doping. Doping of semiconductors. We will talk briefly about semiconductors though, because that's basically what a diode is. And a semiconductor is, well, just that, a semiconductor. It's not a conductor like copper. We know copper conducts electricity well. Or aluminum. This also is a good conductor. It may be called aluminium, depending on which side of the pond you're on. And it's also not an insulator, like, say, rubber. Well, not that. Maybe I should say glass. It's not an insulator like glass. We've got conductors and we've got insulators. A semiconductor falls somewhere in between the two, that when the right conditions exist, current is allowed to pass. This is called biasing. But let's remember, we're talking about bridge rectifiers here. I knew this was an important topic when my wife had seen this in a box and asked me, well, what it is. I told her it's a bridge rectifier. Of course, she's then going to say, well, what's a bridge rectifier? So I began to explain that a bridge rectifier takes power that comes out of your house, one of these outlets here, and it converts this power into more like this power. And that's important because many of the devices we use don't really use this power to operate. They use this power, and then this device converts it to something more like this power. And when I realized that we were talking about electronics and she wasn't falling asleep, I knew this subject was riveting and had to share it with the world. So it was at that point that I knew I had her attention, that I should probably explain the plight of the diode, right? Because you see, there's no shortage of YouTube videos showing how to replace these with, say, something more like this, because this is a rectifier diode, a bridge rectifier. Or you can replace this with, say, 4 of these. Pretty incredible, right? Or maybe even how to salvage a couple more modern diodes and then replace this diode here. And it seems odd that we take these out, these items that have this really neat aesthetic, and we trade that for something that really is so ordinary that you can't really tell it's any different from many of these components. In fact, this one here is also a rectifier, 2 diodes in a package. And we take out something that has some character and styling in favor of something that, well, is pretty plain and ordinary. And we do it for a few reasons. One, we don't want our components downstream from this diode to fail, because let's face it, some of these components are very inexpensive. Even this, to replace this, quite inexpensive. But say a transformer to go out, maybe it's an irreplaceable transformer or very difficult to replace, so quite a bit more expensive. So it makes sense in some instances. And to be fair, I too have changed out many of these more distinguishable parts for items that are modern and more dependable, if you will. However, I've got to say that some of these components here will outlast you and me and the next generation to come. In fact, I'm sure some future time this diode is going to be sold at an estate sale, and some future time, many, many years from now, somebody will be making a video about this rectifier, at which point nobody has seen this thing because we've all come and gone. There will still be those that appreciate old tech and may be able to identify this, but it's becoming less and less frequent to see items like this. So at that point, as I was explaining it to her, I looked over and I could tell that she was captivated. I'm just kidding. She was asleep. So I did what any good husband would do. I woke her up and said, hey, do you want me to show you how this works? She just walked past me and went to bed. I guess that diodes and rectification isn't quite as riveting as I had hoped. But if you guys want to see this work, drop a comment down below and I'll be sure and put this on an oscilloscope and you can see how this converts power coming out of an outlet into something more like this. Before we go, I wanted to show you, remember this box here? Well, this is a second box because it happens that I've got 2 of these rectifiers, oil-filled Selenium rectifiers. If you want to get your hands on one of these, there'll be a link down below for my eBay store. I'm going to keep one for posterity's sake, but I'll be sure and put this one on my store, and that way you can get your hands on one of these and you too could have something to bore your wife to sleep. Thanks for hanging out with me and for staying awake. Have a great day or evening, and we'll see you on the next video. Bye for now. Drop a comment in the description below. Drop a comment below. Oh my word, did I really just say that?